Today we're going to talk about solving equations that actually have more than one letter in them. Yes, they can be solved, but you're not going to get a number for an answer. You're just going to get a group of letters as an answer. So it usually helps if you write the steps for the letter that you're interested in. And by steps, I mean a list of operations that you would perform to that letter. So basically what that looks like is you're asked to solve for y. So if I told you that y equals 2, the first thing you would do after substituting is multiply that by -4. So I'm going to write -4 would be the first step to y. And then I would add a positive 3x to that. So when we solve for y, we want to undo the last thing first. So we would subtract 3x, and then we would divide by -4. I'm just going to recopy my problem here so it's a little easier to see. Y doesn't really equal 2, so don't let that confuse you. So the first thing I will do is subtract 3x. And we have a problem over here. There's no x's to stack 3x with. So if it helps, you can always invent a 0 anything. And then you have somewhere to stack your 3x. So we have -4y equals 7 minus 3x. And we're going to go ahead and divide everything by -4. So you really can't do 7 divided by 4. You can make both the negatives positive, but you still can't do 3 divided by 4. So what you can do is pair up 7 and 3x and put that all over -4. Okay, so if you can't actually divide or you can't reduce the fractions, then it's okay. Just go ahead and pair them together and leave it as one fraction. All right, let's try another one. So example 2, n is what we're interested in. So if I plugged a number in for n, I would first multiply it by 3 and then add 6p. So to solve, I'm going to subtract 6p and I'm going to divide by 3. Now just as a heads up, I don't have a p on the left, so I'm going to go ahead and invent a 0p and add that to my 15. So we will subtract 6p on both sides. And then I will go through and divide every single thing by 3. And these will reduce, so I'm going to have a -2p and a +5. And that's my answer for n. Looking at 3, we're asked to solve for k. So the first thing I would do is subtract 2 and then divide 5. So I will start out by multiplying 5 and then adding 2. So I will have k minus 2 equals 55, and then I will add 55j, excuse me. And then I will add 2 to both sides. I don't have anywhere to put a constant because there's no constants over here, so I'm going to add a 0. And now I do have a place to put it. So your final answer will be 55j plus 2, and you're done. Now looking at the bottom, 4 and 5 are harder because there's multiple things that have our letter of interest. And I can't necessarily subtract SM from 2 because I don't know what S is. So here's a list of steps to help us. The first thing you want to do is distribute if you can. There is no distributing that I can do. So step 2, if you can distribute, sometimes you can combine like terms. There are no like terms on either side. Step 3 is the big one. So you will add or subtract anything containing the letter of interest. So in this case, our letter of interest is M. The reason we do that is because we want our M's on the same side of the equal sign. That's an important step. So if that has to happen, then you will have to undistribute your letter of interest. So let's just start right now with subtracting. There are no SMs over here, so I'm just going to invent a 0 SM. So we will subtract SM from both sides. And keep in mind, you could have subtracted 2M from both sides as well. I just picked SM. So you have negative 1 SM plus 2M minus T equals 5. So we notice we have an M in both the first items in this side of the equation. So what you can actually do is take that M and pull it out of this little group right here. That would leave us with negative 1S plus 2. And if you're not sure about that, go ahead and if you distribute M back in, you get right back to where we were. So we have not changed anything. We're just doing some mathematics to get a little creative here. So once you do that, you make a list of your operations that were performed on the variable, and you're going to undo each item, starting with the last step first. So looking at M, if I plugged in a number, I would have to multiply it by this whole group. After you multiply it by whatever's in here, you would subtract T. So to solve it, we're going to add T, and we're going to divide by negative S plus 2. So go ahead and start with adding T. Since I don't have a spot, I'm going to invent a 0T. And I have M times negative 1S plus 2 equals 5 plus T. And I'm just going to divide by negative 1S plus 2 on both sides. Okay, so you're going to get M is 5 plus T over negative S plus 2. Okay, last one, number 5. So we are, it doesn't say what to solve for, so let's solve for R. Okay. So right off the bat, I see that I have two things that have R's in them, and I don't like this big whole fraction, so I'm going to split this fraction apart. So I'm going to make it 4R over 3 minus 2/3. There is no distributing. I do not see any like terms I can combine, so I have to start by adding R to both sides. And the good news is I have an R stack over here, so I can combine those. So 1R is the same as 3/3 R. 4/3 plus 3/3 makes 7/3 R. And I'll just bring the rest down for now. So looking at R, it looks like we multiplied by 7/3, subtracted 2/3, added K. So the first thing to undo is the addition of K. So I now have 7/3 R minus 2/3 equals K plus P. So I will next add 2/3 to both sides. And since I don't have a constant, I'll invent one. And now I have a spot to put that. And I have 7/3 R equals K plus P plus 2/3. And to undo multiplying a fraction, you multiply by its reciprocal. And I put this whole thing in parentheses and put 3 sevens outside of it, because you have to multiply by everything. And then you're actually fine if you want to leave that. You can distribute the 3 sevens, but it's really not going to change much. So that would be okay to leave it like that. So number 6 gives you the volume for a cylinder, and your job is to isolate H. So it looks like they multiplied H by pi r squared. So we're going to divide by pi r squared. So your formula for H is volume over pi r squared. So because of that, now we can go ahead and put in our 12-foot radius and 1810 for our volume. So volume is 1810 over pi 12 squared is going to equal our height. So I have to think 144 times 3.14 gives us 452.16. So we have 1810 over 452.16. And that's going to give us about 4. So our height is about 4 feet. All right, number 7, the formula S equals 1/2 times A times T squared is the distance for a free-falling object that's near a planet or the moon, depending on the time. So your job is to solve for A. So it looks like for A, they multiplied by 1/2 and then multiplied by T squared. So we will divide by both of those. Okay, so S equals 1/2 A times T squared. So I'm going to start by dividing by T squared. Those cross out. So I have S over T squared equals 1/2 A. And then I need to multiply by the reciprocal in order to divide by the fraction. So if we do 2 over 1 times S over T squared, we're going to get 2S over T squared equals A. So if the moon has a distance, or yeah, I guess a distance of 20.5, so that will be our S, and 5 seconds is our time, we can substitute that into our formula. So A will equal 2 times S over 5 squared. So if I want to multiply 20.5 times 2, that's 41 over 25. And you can just leave it like that. It doesn't come out to a pretty number, but it'll be, I guess I should write 21 meters per 25 seconds. And that's about it.